Best practices we follow to build exciting REST APIs. What is a REST API? An API is a set of programming codes that enables data transmission between one software product and another. It also contains the terms of this data exchange. REST stands for Representational State Transfer. It is a software architectural style created by Roy Fielding in 2000 to guide the design of architecture for the web. Any API, application programming interface, that follows the REST design principle is said to be RESTful. Simply put, a REST API is a medium for two computers to communicate over HTTP, Hypertext Transfer Protocol, in the same way clients and servers communicate. REST API design best practices. 1. Use JSON as the format for sending and receiving data. To ensure the client interprets JSON data correctly, you should set the content type in the response header to application/JSON while making the request. For server-side frameworks, on the other hand, many of them set the content type automatically. Express 4 now has the Express JSON middleware for this purpose. The body parser npm package still works for the same purpose, too. 2. Use nouns instead of verbs in endpoints. When you're designing a REST API, you should not use verbs in the endpoint paths. The endpoints should use nouns, signifying what each of them does. So, for an endpoint should not look like this. Instead, it should be something like this. In short, you should let the HTTP verbs handle what the endpoints do. So, get would retrieve data, post will create data, put will update data, and delete will get rid of the data. 3. Name collections with plural nouns. You can think of the data of your API as a collection of different resources from your consumers. If you have an endpoint like this, it might be okay for deleting a post with a delete request or updating a post with a put or patch request, but it doesn't tell the user that there could be some other posts in the collection. This is why your collections should use plural nouns. So, it should not look like this. Instead, it should be something like this. 4. Use status codes in error handling. You should always use regular HTTP status codes in response to requests made to your API. This will help your users to know what is going on, whether the request is successful, if it fails, or something else. The HTTP 200 OK success status response code indicates that the request has succeeded. The HTTP 500 internal server error response code indicates that the server encountered an unexpected condition that prevented it from fulfilling the request. The HTTP 404 not found response status code indicates that the server cannot find the requested resource. The HTTP 422 unprocessable entity response status code indicates that the server understands the content type of the request entity, and the syntax of the request entity is correct, but it was unable to process the contained instructions. The HTTP 503 service unavailable server error response code indicates that the server is not ready to handle the request. The HTTP 502 bad gateway server error response code indicates that the server, while acting as a gateway or proxy, received an invalid response from the upstream server. 5. Use nesting on endpoints to show relationships. Oftentimes, different endpoints can be interlinked. You should nest them so it's easier to understand them. In the case of getting user details in the example endpoint, we use this. You should avoid nesting which is more than 3 levels deep, as this can make the API less elegant and readable. 6. Use filtering, sorting, and pagination to retrieve the data requested. Sometimes, an API's database can get incredibly large. If this happens, retrieving data from such a database could be very slow. Filtering, sorting, and pagination are all actions that can be performed on the collection of a REST API. This lets it only retrieve, sort, and arrange the necessary data into pages so the server doesn't get too occupied with requests. The one below is a filtered endpoint example. This endpoint will fetch any products that has a lang of enus. 7. Security. SSL stands for Secure Socket Layer. It is crucial for security in REST API design. This will secure your API and make it less vulnerable to malicious attacks. Other security measures you should take into consideration include making the communication between server and client private and ensuring that anyone consuming the API doesn't get more than what they request. SSL certificates are not hard to load to a server and are available for free mostly during the first year. They are not expensive to buy in cases where they are not available for free. The clear difference between the URL of a REST API that runs over SSL and the one which does not is the S in HTTP. Authorization, authentication. Authorization for services is no different than authorization for any application. Ask this question: does this principal have the requested permission on the given resource? CrossOrigin resource sharing. Implementing CrossOrigin resource sharing on a server is as simple as sending an additional HTTP header in the response, such as access control allow origin, access control allow credentials, etc. Rate limiting is a strategy for limiting network traffic. It puts a cap on how often someone can repeat an action within a certain time frame, for instance, trying to log into an account. 8. Be clear with versioning. REST APIs should have different versions, so you don't force clients to migrate to new versions. This might even break the application if you're not careful. One of the most common versioning systems in web development is semantic versioning. These are some examples of semantic versioning. The first number represents the major version, the second number represents the minor version, and the third represents the patch version. Many RESTful APIs from tech giants and individuals usually come like this. API versions way. When you make REST APIs available this way, you are not forcing clients to migrate to the new versions in case they choose not to. It is important to put these best practices and conventions into practice so you can build highly functional applications that work well, are secure, and ultimately make the lives of your API consumers easier. I hope you got a clear idea of the best practices we follow to build exciting REST APIs through this video. Please feel free to share your thoughts and suggestions.